Welcome to PreMath. In this video, we have got this green rectangle fully confined in a blue square, as you can see in this diagram, along with this diagonal AB, such that the area of this green rectangle has been given to us as 15 centimeter square, and the side length of this green rectangle is 5 centimeter. And this AB segment length is 10 centimeter. And now our task is to calculate the area of this blue square. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's suppose that the side length of this blue square is x centimeter, and since all the sides of the square are same, so therefore this side length is going to be x and x across the board. And now let's recall the area of a square formula, area equal to s square, where s represents the side length of the square. So therefore the area of this given blue square is going to become x square, since the side length of the square is x. And now our task is to find the value of x square. And here's our next step. Let's focus on this green rectangle whose side length is 5 centimeter. Let's assume that its width is a centimeter. And now let's recall the area of a rectangle formula. Area equals to length times width. In our case, our length is 5 and the width is a. And the area has been given for this green rectangle as 15 centimeter square. So therefore, I can fill in the blanks in this formula. So we got 15 equal to 5 times a. And now we are going to divide both sides by 5 to isolate a. And here we can see this 5 and 5 is gone. So therefore our a value turns out to be 3 centimeter. So therefore our this a value is 3. If this side length of the rectangle is 3, then this other side is going to be 3 centimeters as well. And in this next step, I have extended this horizontal line all the way to this point. And likewise, I have extended this vertical line all the way over here. And now let's make an observation. We can see that this side length is x. Then this side length has got to be x centimeter as well. And we know that this side length of this green rectangle is 5. So therefore this remaining length is going to be x minus 5. And we know that this horizontal length and this segment length are equal. If this length is x minus 5, then this side length is going to be x minus 5 as well. And likewise this vertical length is same as this side length of the square. So if this one is x, then this side length is going to be x as well. And we know that this length is 3. So therefore this remaining length is going to be x minus 3. So I can write x minus 3. And now let's focus on this right triangle APB. And we are going to apply the Pythagorean theorem on this triangle. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our hypotenuse is 10. And our other two legs are x minus 5 and x minus 3. So let's go ahead and fill in the blanks in this Pythagorean formula. So we got x minus 3 whole square plus x minus 5 whole square equals to 10 square. And now let's recall this famous identity: a minus b whole square could be written as a square minus 2ab plus b square. I am going to apply it on both of these binomials on the left hand side. So therefore the first binomial is going to become x square minus 6x plus 9 plus the next one is going to be x square minus 10x plus 25 equals to 100. And now we are going to combine the like terms on the left hand side. So we are going to get 2x square minus 16x plus 34 equals to 100. And now we are going to subtract 100 from both sides. So therefore this 100 and negative 100 gone. So on the left hand side we got 2x square minus 16x minus 66 equal to 0. And now I am going to divide each and every term by 2 across the board to make things simple. So therefore we can see this become x square minus 8x minus 33 equal to 0. And now we can see we got this quadratic equation, and we are going to solve by grouping and factoring. And you may use the quadratic formula to solve this given quadratic equation as well. And now let's focus on this constant 33. This could be broken down to 11 times 3. And if we subtract 11 and 3, we can get this number 8. So therefore we are going to tweak this middle term. Negative 8x could be written as negative 11x plus 3x. As you can see in this next step, I have replaced this negative 8x by this terms negative 11x plus 3x. And here we can see between first these two terms x is in common, and between last two terms 3 is in common. So therefore I can factor x out, so it's going to be x minus 11 and plus 3 times x minus 11 equal to 0. And here we can see x minus 11 and x minus 11, they are in common. So therefore we can factor out x minus 11 and then times x plus 3 equals to 0. So we got these two factors equal to 0. So I can separate them. I can write x minus 11 equal to 0 and the other factor x plus 3 equal to 0. For this first equation, x is going to be equal to positive 11, and for this second equation, x is going to be negative 3. Now we can see x equal to negative 3 is not feasible since x represents the side length. So therefore we are going to reject this negative 3 value, and we are going to accept this x equal to 11 value. And here's our final step. Now we are going to calculate the area of this blue square, that is equal to x square, and our x value is 11. So therefore this blue square area is going to be 11 whole square, and that is going to be equal to 121 centimeter square. So thus the area of this blue square turns out to be 121 centimeter square, and that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.